let's discuss today's stuff. How to compare two PDFs. So we started our discussion that in machine learning, it's all about space, that you have to learn the space. Actually, all of our learning is about space only. Even whatever experiences we are having, it's all space. Actually, what we have ultimately is only experience, right? How do you know anything? Just from your sensory experience, right? How do I know Nishant is there? Just because I see him or I hear him. I have no other way, means no other way to know him. I've got only 5 senses. And then beyond that, I have nothing. So these 5 senses give me experience, and based on my experiences, I construct a space within myself, and which gives identity to each individual experience and allow me to differentiate them. That okay, Nishant is different from Nitish, is different from Sagnik, is different from uh, Jinang. So in this way, I create my space. Okay, and then uh, I am able to manipulate. I'm able to go about in this world. So similarly, if I want to do anything, let's say in mathematics, I have to construct a space. So now the objects in this space are the PDFs, which means, okay, let us talk about PMFs or probability mass functions, which means that the random variable is a discrete random variable, right? It means, let's say it can take 3 values, 0, 1, 2, or 1, 2, 3. And then you have different probabilities for 1, 2, and 3. And then there is another probability distribution on the same random variable. How do you compare the two? How do you compare that if they are close or far apart? Scale divergence is the most common thing, and we have discussed also in the past. So I'll just go through these things little bit more in detail. First thing which we are going to discuss about on the space of PMFs or PDFs is entropy. What is entropy? Entropy is a measure. It is defined as if your x is a discrete random variable, which means x can take, this means your x can take discrete values, 1, 2, 3, or so on, up to capital N. Then x is a discrete random variable, and you define entropy like this, which means that probability of x, so for a given probability function p, probability function p maps x to a real number or a number between 0 to 1, such that p of x summation over all x is equal to 1, right? That is my p of x. Now p of x log of p of x summation over all x with a negative sign, this is called the entropy. And if it is in continuous domain, you know, you replace the summation with an integral, right? Now this quantity is called an entropy. Now there is a claim that this quantity is always greater than or equal to 0. This quantity called entropy is always positive or 0, which means non-negative. Can you prove it? P of x is always positive. P of x is always less than 1. Therefore, okay, let me write it down. You are saying P of x is always between 0 to 1, right? Which means log of P of x will be always between minus infinity to 0, and you take some, okay, then you can say minus log of P of x will be between 0 to infinity, right? P of x is PDF, probability density function, but for a given value of random variable x. Okay, let us put it more. So x is a random variable, and this small x refers to different values which x can take, right? So P of x is a probability distribution function, probability density function for capital X, right? It can be, what can be greater than 1? Okay, if x is a discrete random variable, then this holds. If it is a continuous random variable, then we cannot say that. Yes, right. So this is only for discrete random variable. Okay, and then you are saying that this quantity will be between 0 to 1, and you are taking summation, and then you can roughly say it is 0 and it is greater than 0. But in what case it is exactly equal to 0? For a okay. Okay. Need not be always less than 1. P of x, if it is PDF and x is a continuous random variable, then it won't be between 0 to 1. It can be greater than 1 as well. Yeah. So this proof is not valid. Okay, fine. I accept. This proof is not valid. So let's find a more graceful proof or a more rigorous proof. So to prove this, let's discuss something called, don't forget the name, let us discuss a very easy to understand concept. This concept is something like this. If I give you 2 points, let's say this is y1, this is x1, this is x2, this is y2. Okay, let me call it as f of x2, right? And this is f of x1, right? There is a function f. If I want to find a point on this line, what will that be? If I want to find any point on this line, can I say this is on the x-axis, this will be, let's say I divide it in alpha 1, alpha 2, or let's say alpha 2, alpha 1. Then you can say my new point here, this x3 is this x is equal to, okay, alpha 1 x1 plus alpha 2 x2 divided by alpha 1 plus alpha 2. And if I say let summation alpha I over I is equal to 1, then this term won't come, right? Because we have normalized it. L1 normalization. So in that case, simply x is equal to alpha 1 times x1 and alpha 2 times x2. And what will be our this point? The height of this? Simple geometry. So this point will be, your y will be equal to what? F of x. But f of x might be some other function also, no? F of x could be, this might be my f of x for any general x. Or let's say this is x3, or let's say x dash to be more precise. Then what is my y dash? What is my y dash? F of x dash. F of x dash is this number. This is my f of x dash, right? Right? But what is this number? What is this value? Yes. So this value is alpha 1 times f of x1 plus alpha 2 times f of x2. And this is basically equal to f of alpha 1 times x1 plus alpha 2 times x2. So which is greater? Which is greater? F of x dash is greater than the other quantity. So I can say my f of alpha 1 x1 plus alpha 2 x2, this is greater than or equal to alpha 1 times f of x1 plus alpha 2 times f of x2 if f is concave is down? Okay, convex. I don't remember exactly. Okay. Okay, whatever it is, but if it is like this, if means if your f dash is negative or f double dash is negative. If your f double dash, which means a derivative, right? The double derivative with respect to x, of course. If a double derivative is negative, then this holds. So let me remove this terminology, which might be confusing. I may simply say if f double dash is negative or less than equal to 0, right? Then this inequality will hold. Do you agree with this? And if f double dash is just a minute. Okay. And on the other hand, if f double dash is greater than equal to 0, then the equality will be other way around, right? Which means it will be like a curve like this, right? Then you will have something like this, right? So in general, I can write, instead of this I can say f of alpha I xi summation over all I is greater than equal to alpha I f of xi summation over all I. Is it correct? Right? In general, if I have more than 2 points, like I have x1, x2, x3, so on up to xn, can I write like this? Do you agree that the point, the new point will lie somewhere in between? It won't be outside this interval? Because if it is outside this interval, then your f will be less than that, right? Do you agree that your point will be inside this interval? So it is true in general also. If you have, let's say, two-dimensional space or even higher dimensional space, if you have points, if you, let's say these are your xi, like x0, x1, x2, or x1, x2, x3. If you take summation over alpha I xi, it will always lie within the, what is it called? What is this area, what is this region called? Convex hull. So which means it lies always within this region. It is also called a convex hull. Just a technical term, but the intuitive understanding is that it is somewhere in between, right? So this point will always lie somewhere in between, this convex hull. It cannot go outside, provided that alpha I summation is 1, right? And alpha is greater than 0. Okay, this is another one. Alpha I is greater than 0 for all I. Greater than or equal to 0, okay, to make it more general. Is this clear? So this is Jensen's inequality. This one. I am sure you have read this in, I think, 11th or 12th standard. Okay, but we are going to use it to prove our inequality. So now log is what kind of function? Logarithmic function. is f double dash is less than 0. 1 upon x and minus 1 upon x square. So minus 1 upon x square is always less than 0. I can say log of, let me put a new page. I can always say log is, okay, f double dash is less than 0, or actually it is less than 0. Therefore, log of summation alpha I xi will always be greater than or equal to summation alpha I xi, sorry, summation alpha I log of xi. Right? Summation over all I. Right? So, can we use this now to prove our entropy thing? So, this is an important result. Please remember it. We will use it in so many places that, at least in today's lecture. So, let's go back to our, we have to prove that this quantity is always greater than or equal to 0. How shall we do it? So I can say h of p of x is equal to summation p of x log p of x with a negative sign summed over all x, right? Or it could also be the integral form for our continuous random variable. So, but okay, I will do it for the discrete form. So, can you compare it? Can you compare these two forms? Summation alpha I xi, summation alpha I log of xi. Does it look something like alpha I? This quantity, right? Because you know alpha I means basically is greater than or equal to 0 and it sums to 1, right? So I can use Jensen's inequality to write what? I can convert this into, let us consider without the negative sign first. This quantity, which is like not considering the negative sign, this quantity will always be less than or equal to log of summation px into px, right? Oh, xi. Right? Can I write like this? This means basically the square of this term. Now, can I say this quantity is always, okay, so let me take the h term now, which will be greater than or equal to minus log of p square xi summed over all I. Now, summation over p square xi, what can you say about this? This quantity will always be less than 1. Why? Summation of px is 1. Okay. Yes, you are right. So this term will always be less than or equal to 1. So basically log of, so basically p of x, p square xi summation will always be less than or equal to 1. Therefore, log of this term will always be less than or equal to log of that term, 0, because log is a monotonous function, so you can say this. And what about negative of this whole term? This is always greater than or equal to 0. And you know h is always greater than or equal to this term, so h will always be. Now the question is, when will my h be equal to 0. When will h be? So this proves that h of x or h of p of x is always greater than or equal to 0. Yeah, yeah. No, Jensen's inequality will take another form in that continuous domain, right? P of x is always less than equal to 1. Oh, okay. Okay. Got your point. Let me get back to this, but okay, let us do it for the discrete case for now. So h of px is always greater than equal to 0, and when will it be equal to 0? When will it be equal to 0? Huh? When p of xi is equal to? Yes. So basically, when you are, so this equality will hold originally when this equality will hold, right? This is our starting point, right? So when will this hold? This will hold when this sum is exactly equal to 1. So this sum will be exactly equal to 1 when uh, px is delta function, right? When your p of xi is equal to some delta I something, I star, right? When it is 1 for only one single I, then h of p of x is equal to 0. Okay. For the continuous case, you have to prove that integral of p square x is less than equal to 1. So we are not putting a constraint on single value of x or p of x. We are putting a constraint on the integral, right? So you have to prove that, okay, in continuous case, px dx summation is equal to 1, then you have to prove that p square x dx is less than equal to 1, right? Uh, I don't know. Schwarz inequality.
The square root less than product of integral.
Yeah, right. So you can use Schwarz inequality, which says right. Okay, fine. So let us come back to our discrete case, in which now I have proved that h of p of x is always greater than equal to 0, and it is equal to 0 when it is a delta function, right? Which means I know the value of x exactly. Means probability of x is 1 for one particular x. Means x is always, x takes that value only. So, and when is it minimum? Oh, okay, we have answered that. Is there any upper bound on h of p of x? Is there any upper bound on h of p of x? Yes. Is there any upper bound? How do you prove that? Should we use it as a homework problem? So prove that h of x is upper bounded, and what is the upper bound, and when is that bound achieved? Okay. To give you a hint, it will also include Jensen's inequality, but use it in a different way, slightly different way, and you'll be able to do it. Okay. So okay, I'm not doing it. So let's go to the next slide. Huh? Pardon? Maximum for equiprobable or uniform distribution. Yes. Yes. But you have to prove that. Cross entropy between two PDFs. Okay. Now I am given single random variable but two different probability distribution functions, right? That is possible. I may have different PDFs. Like in neural networks, you have seen when you are in your multi-class classification problem, you have got you want to predict the value, right? So your one random variable, basically the class is the random variable. So the ground truth is a delta function, right? It says, okay, I know this is the class, and your estimate is a not a delta function, but you want to make it a delta function. So the same random variable, but the distributions are different, and you want to make them same. That is how training takes place, right? Okay, now so we come to the concept of cross entropy. In neural networks, you have also seen cross entropy loss function, binary cross entropy, categorical cross entropy, right? Now, what is cross entropy? A general definition is h of px comma qx. The same thing, but now instead of saying px log px, we are saying px log qx, where qx is a different distribution on the same random variable. For discrete case, for continuous case, it is also always greater than equal to 0. The proof is similar. This is always greater than equal to 0. When is it minimum? This is the question now. When is this minimum? When will this be minimum? Cross entropy is minimum when? Pardon? If they are both identical, then it becomes h of px comma px, which is entropy of px, and you know it lies between 0 to some value. So if they are identical, then they are not 0. The cross entropy is not 0. Uniform distribution. Again, a wild guess, miserably wrong. If both px and qx are uniform distribution, which means px is equal to qx and they are uniform distribution, this means entropy is the maximum. Don't make wild guesses. Okay, solve it on your own. Good answer. Now you are thinking. So basically, you know h of p of x comma p of x is always greater than equal to 0, and this is equal to 0 when delta function basically, right? When you have a delta, when both are same, when both are 1 for same value of x, then the entropy is 0, right? So yes, it is always greater than equal to 0. You can prove it using Jensen's inequality the same way. And when is it minimum? It is minimum when p of x is equal to q of x is equal to a delta function, right? Is it upper bounded? Is it upper bounded? Is there any upper bound on h of px comma qx? Should I do it or should I leave it for you? Okay. Let me do it for you. H of px comma qx is equal to minus summation over x of, let's say, summation over I p of xi log q of xi. I can always choose, let's say p of x is my uniform distribution, right? Which means, let us say I can take n values. Then this will become 1 upon n. This means p of xi is equal to 1 upon capital N for all I. Now this formulation becomes summation over 1 over n log of q of xi. Now if I take q of xi to be 0 for any xi, then my h will become infinite, right? Let's say if I make For a particular I, for I star, q of x of I star goes to 0. I mean, it is equal to epsilon. Epsilon is very close to 0 or tends to 0. Then my h will tend to infinity, right? Then h will go to infinity. So it is not upper bounded. You are proving it by taking an example and showing it. Yes, for this example it is not upper bounded. So in general it is not upper bounded. Now coming to next concept, which is another measure to find distance between two different distributions or two PDFs or two PMFs for the same random variable. This is, all of you know, KL divergence. What is KL divergence? Basically, it is px log of qx upon px summation. Can you express it in terms of entropy? Can you express KL divergence in terms of entropy? Right? How will you do that? So you can say this term is equal to minus summation px log of qx plus summation px log of px, right? What is the first term? It is entropy of p comma q. And what is the second term? Minus entropy of right? So yes, you can write it in terms of entropy. Now my claim is it is also always greater than or equal to 0. Can you prove that? This term, KL divergence, is also always greater than or equal to 0. Just go to Jensen's inequality and you can solve it very easily. Just use Jensen's inequality and you can prove it. I think you must have done it in the past, that KL divergence is always non-negative. If you use Jensen's inequality, you can find it. When is it minimum? When is this KL divergence minimum? Huh? H of? If Px is equal to Qx, then this term basically becomes log 1 always. Log 1 is always 0. So summation over 0, so it is always 0. Then KL divergence will be equal to 0. Okay. And then you can prove it that is always greater than or equal to 0. It is 0 when only when Px is equal to Qx. Is it upper bounded? Is there any upper bound on Px? Also KL divergence of Px and Qx. Is there a maximum value of KL divergence? No. Why? Same example. You can construct an example like take Px as random variable and Qx as for a particular x it goes to 0. Then your log of that term will go to minus infinity and whole thing will become plus infinity, tend to plus infinity. So it is not upper bounded, right? Okay. In general, okay, fine. In general, if you want to find distance, if you want to construct a space, and you want to construct distance, if you want to consider distance between two different PDFs, what will you use? Can you use entropy or cross-entropy? Entropy is for single PDF, cross-entropy is for two different points. Can you use cross-entropy as a distance metric? Can you use cross-entropy as a distance metric? Yes, please. How many of you say no? 6, 7, 8 maybe. How many of you say yes? Why do you think, Ritesh? Why? Why not? Okay. Why is there a problem?
It's not symmetric.
It is, that is fine. Distance can be non-symmetric. Yes. Good point. So, what else? Panchajanya's point is that px and qx, so distance metric should be 0 when px is equal to qx, right? When the points are same, the distance should be 0. But this cross entropy will be 0, yes, when they are same, but not all the time. Even if they are same, it may be non-zero. But when they are equal to delta function, then it is 0. So can we use it as a distance metric? No, if they are not a delta function, but if one of them is a delta function, then yes. That is why we used it as a distance metric in our neural networks, right? We have used it, but in that case, we did have a delta function. Okay? Okay, can we use scale divergence as a distance metric? Yes, and always, because it is always 0 for the when 2 points are same. Okay. Next is, if I have more than one random variables, I have two random variables, then what do I do? How do I find distance metric between two different random variables? Can I construct a distance metric between two different random variables? So I use something called mutual information. So mutual information between two random variables is h of x minus h of x given y, and we can express it in terms of KL divergence. That is a simple manipulation. You already know the formulation of that. Okay, h of x comma y minus h of x is KL divergence. So you can say, basically, if you open it up and express it in terms of PDFs, then yes, you can do it. And this is also always greater than equal to 0. How will you prove it? Again, using Jensen's inequality. You can prove that this is also always greater than or equal to 0. Okay. Let me write down the expression in terms of KL divergence. So my mutual information I, x comma y, is equal to, let's say, summation, what is it? H of x minus. What was it? H of x, px log px, the negative sign, and then minus h of x given y. Okay. Plus how do we prove that this is equal to, how to put it in terms of KL divergence? Okay, let us first open it up. We can say this is P of x comma y upon P of y. I think it is comma y here. This term is same, basically. How do I prove it in terms of KL divergence? I have to make it, okay, let us try this way. X comma y, P of x comma y, P of x, right? because it is marginalizing over y. This expression is marginalizing over y. Now what do I write? I have to merge the two. This is equal to summation p of x comma y. How do I get rid of this p? I think I'm doing some mistake. I think this p of y is not there. Let me reconfirm. Okay, I'll get back to this proof maybe later. I'm doing some mistake. I missed some formula here. So okay. So let's go to the next part. I'm now revisiting the neural networks. So we have discussed multi-class classification. This is another view to see the same problem. There was a question from somebody, Sagnik, I think. So I'm answering your question in this slide. So we have multi-class classification problem. There we have, we can interpret it in terms of random variables. Now, for multi-class classification problem, I have a single random variable called the class. And it can take n different values, 1, 2, 3, 4 up to n, right? And now my output of the neural network is a PDF. So y of c, where c is the class, is a PDF, so that all my y's, like summation of y of c over all c is equal to 1, and yc is greater than 0 or equal to 0 for all c, right? So this is my y of c, the output of the neural network. And I compare it with the ground truth, which is another PDF or PMF, and it is 1 for a single value of c and 0 for all other values of c. So these are two different PDFs which I am comparing with the help of which distance metric? Cross-entropy, right? Why can I use cross-entropy? Because I have seen that it can be used as a distance metric if one of them is a delta function. So we can use it here. Okay, and the metric, so I can construct a metric cross-entropy to quantify the distance between these two PDFs, and that's what I did in case of multi-class classification. Is this point clear? Okay. Next is multi-label classification. In this problem, I have got single random variable. So the output of the neural network is, let's say, this y's, but their summation is not equal to 1, right? Because I know at a time several values can be 1, several labels can be true. So I cannot interpret them as a PDF. But I know each of this neuron has a binary interpretation, or it is either 0 or 1. So I can consider that as a random variable. So I have got n random variables, capital N random variables. Each random variable is a binary random variable. It can have value 0 or 1, right? And now I can construct PDFs. So I can say the output is, let us say this is the output neuron. I can interpret it as estimating y of li is equal to 1, because I'm, let's say, considering on and off case. So let us say the output of neuron is when the label is true, when L is 1, right? I can interpret it like this. And then this is one PDF, and when L is equal to 0, it is simply, where is it? L can take only two values. When L is equal to 0, the probability will be 1 minus the other probability, right? This expression will hold. So my y can be one PDF, and similarly my ground truth t can be another PDF. It is also a binary random variable and the corresponding PDF. Then I can construct a distance metric which can be a cross-entropy function, right? Why? Because one of them is a delta function. One PDF is delta. So I can construct another cross-entropy function, and it can be written like this. t of 0 log of y of 0 minus t of 1 log of y of 1. And since I know my y of 0 is 1 minus y of 1, so I can replace it that way. And I get back my loss function for binary cross entropy, right? So both are cross entropies, but this is called a binary cross entropy, and the earlier one is called a categorical cross entropy, right? So this is the PDF understanding. Okay. Now this is the topic which we want to discuss actually today. This is called EM algorithm in general. So we saw in the past when we were discussing about k-means clustering as well as GMMs. When we were discussing, we saw that in GMMs you have got different clusters of data, and you want to model each cluster with a Gaussian, right? And your whole PDF is something like summation over probability of some z, and then normal distribution that your, okay, let's say z, okay, zk, normal distribution of x given mu k and sigma square k, and summation over all k. This was your probability of x, right? This was your GMM, Gaussian mixture model, where z is your latent variable, right? So this is one kind of latent variable model. I can construct so many latent variable models. Basically, the idea is that you have got some hidden or latent variable which is capturing the different heaps, and each heap can be separately modeled as some PDF, either Gaussian or whatever. So this is the idea of latent variable model. So generally, when we write the loss function, then it can be p of x comma z given theta. So basically, you have to maximize likelihood, which is probability of x given theta, and you write it as for p of x comma z given theta summation over all z. You're marginalizing over all the latent variables, and this you see when you take a log likelihood, then you get a log of summation, which is not a nice thing, right? So can I convert log of this thing, which is basically log of summation over something, into something which has no summation? Summation is not there. Why do we want to do this? Because analytically that is easy. If I differentiate, I do not get any theta terms in the denominator because of this, right? Because summation, all theta terms will go to the denominator, and then you have difficulty in finding analytical solution, right? That is why we want to avoid that problem. Maybe it's okay. This is the problem that, okay, when you take log of p of x given theta, this is the log likelihood function. If you expand it in terms of latent variable z, then you get log of summation, which is difficult to, when you differentiate it, it is difficult to solve analytically for the particular parameter value, right? Can you get rid of this? And you have today seen how to convert log of summation into summation of log. How do you do that? Using Jensen's inequality.